So let me just wrap up one thing with the class, and then I'll kind of turn it over to you. So there's another batch of slides, everybody, that I'll just go through next class, where we're going to go into a little bit more detail about kind of layer 1, layer 2 technologies, talk about the use of airdrops and how to structure airdrops so that they're effective. But I think it actually works out well that Ritvick is going to be speaking first, because that will set up a lot of the conversation about layer 1, layer 2, and how ICP has thought about things very differently, so that they're able to achieve scalability on their system. So with that, let me introduce Ritvick. Ritvick and I got to know each other recently through a mutual colleague in ICP named Javier, who does a lot of the ecosystem and community management. I got to know ICP through doing some writing about it about a year and a half ago, and it just was really interesting to me because it was very different than Ethereum, Solana, and the other things that are out there. So with that, Ritvick, let me turn it over to you, and you can share screen and maybe give a quick intro about yourself, and then jump into the slides.
Sure. So I have to share screen with the class, right? Not with the table.
Share, yeah. See if you can share screen with the class. If I think I might be able to make the table visible to everybody.
All right.
Okay, perfect. Yeah, we can see it.
All right.
Wonderful.
Hello, everyone. My name is Ritvick. I'm the tech advisor at ICP.Hub North America. ICP.Hub North America is one of the hubs across the globe where these hubs are spreading the word of the Internet Computer Protocol itself. And these are the communities where everybody could come in and collaborate and potentially build on the Internet Computer as well. I'm also the founder of BlockCypher.ai. It's an AI-based analytical platform specifically targeting whatever on-chain data resides on the Internet Computer Protocol. Today, I'm here to talk about...
Really quick, do you mind putting that as full screen? Wonderful. Right. Okay, continue.
Perfect. So today, I'm here to talk about the Internet Computer, what it is, from where it started, and how it differs from other blockchain technologies. So Chris, if you can help me understand what's the level of the class? Do they know about Bitcoin and Ethereum already?
Yeah, so the audience, so everybody in the class is, so these are master students. I think everybody's very familiar with kind of the core around how BTC works, et cetera. But I think it would be helpful to juxtapose ICP and how it's different from the consensus mechanisms that exist on other blockchains. So assume definitely a core understanding, but feel free to rehash anything that you think is relevant.
Perfect. All right. So yeah, so initially Bitcoin was introduced in 2008, and we saw a ledger-based technology which was just keeping records of the money movement, which was Bitcoin. And then the algorithms which used to mine Bitcoin were very computational heavy, right? They were solving some complex mathematical problem just to agree on who the miner will be able to add blocks to the Bitcoin chain. Ethereum was also created on the similar methodology, but it also added functionality to execute programs on the Ethereum blockchain, where you could basically pass in an input to a software program and it can produce an output, and that output could be agreed upon by the multiple miners and could be stored as part of a new block on the Ethereum blockchain. Recently, down the line, 1 year back, Ethereum moved from proof of mining, where they were solving like complex problems, complex mathematical problems, just to agree on who will add the block, to proof of stake, where only few nodes will be running, and we do not waste unnecessary power in the computational of who will be adding the blocks to the blockchain. Now, since then, and even since 2017, we have seen a lot of chains either being classified as proof of mining or proof of staking, and both differs in their own ways. And then the idea of Internet Computer was realized, where rather than just classifying a blockchain as proof of mining or proof of stake, Internet Computer came as a decentralized cloud itself in direct competition with monopolistic cloud providers like AWS and GCP and Azure. So today we'll talk about how internet computer is different from Bitcoin, Ethereum, layer 2 protocols which are working around the Ethereum blockchain. So to sum up with, the novel consensus mechanism on the internet computer protocol is itself very proprietary in nature. Uh, when I say this, it is because the internet computer is architected a little bit different. To show you guys a context, if you go on dashboard.internetcomputer.org, you'll see these are all the machines placed in highly sophisticated data centers. And even these machines are not just ordinary computers where, let's say, a person could run it from their home hardware. These are highly specialized servers with the latest series of AMD EPIC processors, high amount of compute, high amount of RAMs in them, and these servers are guaranteed 99.99% availability by placing them all around the world. Now, one could ask who has placed these servers all around the world. It's not just one company, in contrast with AWS or GCP or Azure. These are like individual people like me, you, people who know a little bit more about servers, Linux servers, data center hosting. So what they do is they basically go and get into a co-location contract with a data center. They rent a rack there, and then they basically purchase 12 to 14 of those servers, and then they place it across the globe. So this way, the decentralization nature of the internet computer is achieved, and the network incentivizes those people who would want to put servers even at more remote location. And the technical function they use is the um, Nakamoto coefficient to basically figure out the exactly the geographical location where you would want to put servers and how many servers. And it's a function of two or three different unique parameters. Geography is one, who is providing the servers is two, who operates the data center is three, and then there are a couple more minor to enhance the diversity of this coefficient. Now, each of these servers, so let's say, for example, in India, there are 14 servers. In US, there are many servers, right? Around 100 and 200, I could see. One server from each country makes a subnet, basically. So on internet computer, you could have multiple sub networks, essentially. And they plan to have 40 of those subnets differently. Now you can think of all these subnets as an individual blockchain in itself. A subnet is achieving to a consensus where all these machines were almost same in configuration. They achieve the consensus in a deterministic time, and then due to their high availability and high bandwidth, the block time is almost sub seconds basically, and it reaches finality very quickly. So this is the infrastructure layer of the internet computer protocol, where these servers are high in compute and they are geographically distributed essentially. So these servers only do essential work. So rather than Bitcoin solving a random mathematical problem, these servers will only perform the computation which is needed to execute a smart contract on the platform. Now, since its genesis over the past 2.5 years, ICP haven't seen any significant downtime at all. They do have a private testnet, which is with the Definitive Foundation itself, which oversees the development of the whole Internet Computer Protocol. It's not for profit, but the testnet is not available to the general public. The general public, we just have this particular mainnet, and whatever software we develop, we directly develop on chain itself. Now, to give you a contrast, how efficient in terms of environment and pollution this internet computer blockchain is, since it is only doing proof of useful work for whatever amount it needs to work for, a Google transaction would consume or will produce at least twice the carbon to the environment as compared to the ICP blockchain. And one of the cool feature about Internet Computer Protocol is that it supports smart contract, which can even store data inside them, and that data could be private. So essentially, you are looking at a smart contract having certain amount of data where you could even store sensitive information. Unlike Ethereum, unlike Solana, where everything is available on public ledger and you have 100% transparency there. Here you have the capability to store certain data in a very private manner as well. And we'll see a very beautiful use case because of this feature, which only exists on Internet Computer Blockchain as of today. Now, obviously, since these are very, very highly specialized servers sitting in some of the data centers, highly available, the cost of executing a transaction on ICP is also very, very low in comparison to other chains like Bitcoin, Ethereum, Solana, even Cardano. And you could scale infinitely. As I mentioned, you right. Everybody will just have to provision more servers within their rack, and then you can create a different subnet out of it. And that's how Internet Computer will scale infinitely as and when needed. One of the cool features which I personally like about Internet Computer is the reverse gas model. So for example, if you are a user and you would want to interact with Uniswap on Ethereum or any other gaming DApp on any other blockchain, ultimately it's the user who has to pay a fee out of their own wallets, right? On Internet Computer, the fees are prepaid by the developers, by the community, by the DAOs who own those decentralized applications, and user like you and me do not have to pay any fee upfront. What this helps users to easily browse social networking dApps which are completely built on chain without even paying any penny from their wallets. In terms of costing, the storage is much cheaper on Internet Computer Blockchain, even comparing it with other decentralized storage technologies in the market like Filecoin, Arweave. If you have to store 1 gig of data on Internet Computer Blockchain as of today, you'll be hardly spending $6 to store that amount of data for a whole year on the Internet Computer Blockchain. It's multiple million times cheaper than what you could store on Ethereum. Apart from this, one of the last coolest feature which I always talk about a lot is the ability to consume Web2 data from within the smart contracts directly. That is the capability, we call it direct HTTPS outcalls, where let's say if you're executing a smart contract on the Internet Computer and you want to fetch weather data, or you want to fetch stock price data, or you want to fetch any data from our traditional legacy Web2 systems, you could easily make a Web2 HTTPS call and get that data. And once that data is gotten into the smart contract, every machine who is validating and achieving to consensus will validate that the correct data is ingested into the smart contract. This completely eliminates the need of layer one blockchains which call themselves as oracles, right? Sitting between the Web2 world and the Web3 world. There is no need of oracles on the Internet Computer. They are essentially baked into the protocol itself. Now, apart from this, Internet Computer also has the ability to host full stack on the blockchain itself, right? As we know, it is a decentralized computer. So you could store your backend smart contracts, which can have a private data inside them. Also, you could store front-end applications written in React.js, AngularJS, Vue.js, which will talk to these smart contracts in the background on the chain itself. This gives a one layer more trustfulness nature to Internet Computer Blockchain, where nobody could even tamper with these front ends which are hosted on the blockchain itself. Imagine today you are using Uniswap or any other Moonswap, any application on Solana or Ethereum, but the front end of those applications reside on CDN providers like Cloudflare, AWS, and whatnot. And then there is always a possibility somebody hacking into those front-end codes and modifying the behavior of the front-end application. Saying that, the applications which are hosted on the Internet Computer completely in a full stack manner are discoverable by our search engines as well. So if you look for a social networking dApp on Internet Computer, Google might even tell you, hey, Discover is one of the social networking dApp which is completely built and hosted on the blockchain. And this is in contrast with, again, Ethereum and Solana, where though there are smart contracts, but they are not searchable, right? And then dApp apps like DeFi Llama and other third-party providers will come in who will index those data and try to make sense of what those smart contracts are doing. Another thing about Internet Computer is the Internet identity. So for example, every identity essentially is a public-private key pair, right? And then certain combination of those. On internet computer, the identity protocol is also baked into the protocol itself. So rather than the identity sitting on a MetaMask wallet or sitting inside a Ledger wallet, you could directly go to a browser and create an internet identity um, from the internet computer protocol itself. And then you could use this identity to interact with multiple dApps wherever there is a user recognition. One of the cool feature of internet identity is that, let's say, for example, if I'm talking to one dApp, which is a sort of a Uniswap dApp, right? And then there is another dApp, which is a social networking dApp. Using my internet identity, if I talk to dApp A and dApp B, both will essentially see a different identifier of the same identity. And this helps prevent tracking of the user behaviors on multiple dApps. In contrast to MetaMask, right, where if I would interact with MetaMask on Uniswap, and if I use MetaMask for gaming application, everybody can basically correlate what this particular identity as a wallet is doing between multiple dApps. So this is one of the privacy enabled features on the internet computer as well, where dApps do not see identities of the user. Now talking about the governance and the ICP token itself. Now let's compare this ICP with Ethereum. What is happening on the Ethereum network? So I think on Ethereum network, there are around 1,800, I'm not sure of the numbers. Those are the validator nodes, right? Which essentially validates and add block to the chain. And in order to be a valid validator, you would want to have certain amount of Ethereum staked inside that validator, right? The current requirement is 32, but then multiple people will come in and then they'll basically what do you say, start providing stake to those validators to increase the credibility of those validators. On ICP, the staking is not similar to what is happening on the Ethereum. As we already know, we have a different infrastructure layer to execute the smart contracts, to process the inputs to the output, and staking is totally used for a different purpose. Staking is currently being used only for the governance of the protocol. So let's say if I own some ICP token, I have to stake it. I have to stake it for a minimum 6 months in order to be able to vote on new proposals, what the Definity Foundation or what the community wants in order to be built on the ICP protocol itself. So essentially, we could say ICP right now is being used for governance of the Internet Computer Protocol itself. Also, it is used to pay individual entities, very similar to Bitcoin and Ethereum. You could pay your friends, and or you could even use it as a money. ICP is also used to convert it into cycles. Now, cycles are, you could consider this as a computational unit on the internet computer chain. So remember those dApps which are running on these servers across the globe, they need XTC, they need cycles in order to basically run on those computers. And then there is a fixed cost matrix of how many cycles you would need to, let's say, do 1 million execution of instructions, or to store 1 gigs of data on the internet computer protocol. And these cycles can only be obtained by burning ICP. So it's a deflationary aspect of the internet computer protocol, where ultimately more ICPs will be burned if the network is being used more, basically. And once an ICP is burnt and converted to cycle, it is just a one-way transaction. You cannot again convert back cycles to ICP. So that way we ensure ICP becomes remain deflationary over the course of its growth. And the last purpose to use ICP token is to basically invest into DAOs. We'll talk about this a little bit later. So if you would want to stake your ICP, you could scan this QR code, or you can easily go to just search on Google like how to stake ICP as a utility token, and you'll have a whole flow there. Now, ICP is the first chain to achieve DAO first architecture on the Internet Computer Protocol. What do I mean by that is, using service nervous system, it's a technical term, but it's essentially a framework by which a project could be DAO from day one. It registers as a DAO on the Internet Computer Protocol. It raises funds using this framework itself. So people using their ICP tokens will come in, contribute to your projects. You'll collect money in ICP. Essentially, this framework will issue tokens to those who would have invested. And this tokenomics is flexible, basically. So there are certain parameters you could configure, and then you could create your DAO from day one on ICP. And the funds which are received by this DAO, they do not belong to any centralized entity, and they'll not be also be available to you on the very day one. There is a vesting schedule for these ICP tokens, and essentially they will be vested over the course of time for the founders, founding team, and the initial team members. And the ICP which is received is stored in a treasury basically, and money could only move from treasury once there is a proposal being voted upon. And who will vote on the proposals? The people who have tokens of these DAOs or these projects basically. And this is essentially what I just summarized how the DAO essentially works. One of the biggest example is the Open Chat. Open Chat is a very application very similar to WhatsApp, but it's end-to-end encrypted. Also, the chat between you and me, no one else can see because of the private state of the canisters. It can store private data. And Open Chat DAO was the first DAO to do to who used the SNS framework to basically raise funds, and they closed around $5 million in just 6 hours. They had a POC, they had an MVP, but they became the first DAO on the Internet Computer blockchain, and you could see like how the tokenomics was initially allocated there. And since past 2.5 years, we have seen exactly a replica of every application which is being which is existent in the traditional world, and somebody is developing a clone for those applications on the Internet Computer blockchain. So consider being a YouTube, Spotify, Twitter, Gmail. There is an analogous for these applications on the Internet Computer ecosystem, and all these applications. From what I understand, most of the applications would want to become a DAO in the future. So it would be very exciting, to keep track of these dApps, what they are doing, what they are building, and essentially, if they become DAO in the future, it's a good way to basically be a stakeholder in those dApps as well. Now, if as Chris mentioned, you all are master students and you would want to try build a dApp on the Internet Computer Protocol as well, there are many languages which you could use. Motoko is the native language of the Internet Computer Protocol, but it also supports Rust, as the output of any program has to be WebAssembly, and then Internet Computer can basically understand how to execute those WebAssemblies. Apart from that, we also have TypeScript and Python. These are essentially some transpilers written on top of Rust, where if you want to write code in TypeScript and Python, you could do it. A transpiler will basically ultimately compile it to Rust and then to WebAssembly in the future. But I would recommend go with Motoko, as that's the most powerful and the native language. It supports any cutting edge feature which is being developed on the Internet Computer as well. Now, in the interest of time, I'll just share one cool feature which I initially mentioned regarding the Internet Computer Protocol was it has direct Bitcoin integration. Now, what do we mean by direct Bitcoin integration? On Ethereum protocol, if you have to trade a Bitcoin with, let's say, Ethereum or any of the ERC20 token, what would you do is you'll go to a centralized exchange like Binance, or you'll go to Coinbase, and you'll get a wrapped version of Bitcoin, which the Ethereum protocol can understand, right? Because Ethereum protocol doesn't understand the Bitcoin protocol. So you'll rely on these centralized entities, get those wrapped Bitcoins, and then you will basically wish those exchanges don't go bad and they are not mishandling the user funds and whatnot. On Internet Computer, you could basically use a real Bitcoin. When I say use a real Bitcoin, what do I mean? So from within the ICP smart contract itself, you could create a wallet which is stored 100% on chain itself. And then if you transfer money from Bitcoin address A to Bitcoin address B, the real Bitcoin will be moved on the Bitcoin ledger from the smart contracts which are residing on the Internet Computer Protocol itself. So that way, there are like many applications which you can think of, multi-custodial wallets directly built 100% on chain, a decentralized exchange which can let users trade real Bitcoin with real assets on the ICP network. And soon, Definity is also working on to integrate Ethereum as well, and this will expand the scope to unlimited capabilities, where ICP protocol will be able to understand what is happening on the Ethereum protocol, and then you could create wallets on the ICP network itself, which will be able to move real Ethereum on the Ethereum network, or even move ERC20 20 tokens on the Ethereum network. Now, moving Bitcoin, even on the real ledger, it's a cool feature, but it comes at a cost, right? It is costly to move real Bitcoins on the Bitcoin ledger. And that's where on ICP, the foundation invented CKBTC. CKBTC is a wrapped version of Bitcoin you could think of, which is a ICP native token, but it's one-to-one correlated with Bitcoin. The only difference is you do not have to go to any centralized exchange to basically procure the CKBTC. Since the ICP protocol have the direct capability to store the Bitcoin wallets, CKBTC has one-to-one peg with Bitcoins, and those Bitcoins are owned by a smart contract sitting on the Internet Computer Protocol itself. So no matter if an exchange can go down, you can always come to this particular ICP blockchain and then exchange your CKBTC for the real BTC. And as I mentioned, Ethereum integration is in testnet. It's a work in progress right now. The ICP ecosystem is growing a lot. A lot many new developers are contributing to the ICP network, and I could see this as so one should not just think about ICP as a money movement or a proof of stake chain. It's a decentralized cloud with all the capabilities of a layer one blockchain. There are some governments building on ICP2. They are showing some trust, which in the fields of 100% certifications of those products. And then let's talk a little bit about the foundation itself. This is the only foundation with maximum number of PhDs researchers and who are chunking crypto day and night. And this whole team consists mainly of the researchers, basically. And the Dominic William, he is the founder of Internet Computer Protocol. He was in the conversations early time as well with Vitalik and other people who were envisioning Ethereum at that time. He was directly envisioning a internet computer, what we have today, and he's a scientist as well by himself. Thank you so much. I'll open the forum for questions now.
Yeah, thank you so much, Ritvick. I mean, two things I want to go back to. Number one was the slide around privacy and the individual identifier, because that's so different than, yeah, I mean, like ETH. It's like, okay, you store ETH in your wallet, which has linked to your identity. But maybe talk one more time about that identity, and then talk a little bit more about the incentive mechanism around the deflation and what you were saying about burning the tokens.
Perfect. So let's talk about the identity, right? So there is one internet identity that is basically to interact with the dApps on the Internet Computer Protocol. And the beauty of those identities are, let's say if you're interacting with dApp A or dApp B, both dApps see a different identifier, and they cannot know that it's the same user who has come to our platform. That's internet identity. Now, smart contracts having the capability to store sensitive data, and these data is stored on each machine in a subnet across the globe. You could even store Bitcoin private keys inside it. And with that, you could essentially, if you have the Bitcoin private keys there, then you could basically write some of the functions to transfer Bitcoin on the real Bitcoin ledger. That's the functionality which is supported. Does that answer your question, Chris?
Yeah, no, that's great. I mean, thinking about it as a data storage mechanism is really interesting. And I mean, a big problem with Ethereum as well as with the NFTs and like where are they stored. So that's helpful. Does anyone from the class want to jump in with any questions before? Let's see, put it in the chat or just feel free to. Yeah, great. Yeah, Jonathan, go for it. And yes, Marlene, I do have the slides, and as long as Ritvick is okay with my sharing them, we'll put them up on Moodle.
Yep, no worries. You can share.
Hey, Ritvick, thanks very much for the presentation. So my question relates to how would using a VPN contribute to internet computer and like in terms of your connection speed or like latency and overall user experience, basically. Would it impact it at all? And if so, if you could just like shed some light on the pros and cons, if any.
Yeah. So using VPN will have the same behavior as if you're talking to Facebook.com, Google.com, or you're interacting with any dApp on the Internet Computer ecosystem. So if you see across the globe, we have these blue blue circles, and these are the validation nodes who are achieving to consensus, storing the data, providing the computer and everything. And then there are some of these nodes which are marked in purple. These are called the boundary nodes, basically. So essentially, these are the gateways, the HTTP gateways, in as an entry into the Internet Computer Protocol. Right now, there are few boundary nodes which are placed across multiple continents and geographies. Later down next year, definitely will plan to even decentralize these boundary nodes a bit more. They are right now researching what should be the exact coefficient to decentralize these boundary nodes. But then you'll see at least one boundary node in every of these blue circle as well. So that way, if you're using a VPN from India, you'll essentially talk to a boundary node in India. If you're connected to a VPN in the US, you'll essentially be talking to boundary nodes in the US. And that way, you're even using even with VPN, access to internet computer should be seamless in my opinion.
Okay, great. Thanks very much.
Any other questions?
Yeah, I have a question. Hi, Ritvick. Thank you so much for sharing and coming to class with us today. So this class is based on tokenomics, and so I'm quite familiar with ICP. And the question is really related to price volatility, and what lessons can one learn as we start to develop either an ICO or a token of ourselves, based on understanding ICP started at a price point or went as high as 700 and has gone down to $5. What are some of the things that we can learn, and what are the pros and cons that have impacted ICP into the company that you are today? And any knowledge that you could share with us as well that we could learn from that. So please, if you could share anything.
Yeah, sure. So I think the price of the ICP got manipulated a lot, just because I think, and these are my personal reasons, it was a big competitor to most of the other chains as well. Secondly, ICP token was launched on the almost on the peak of the bull market, right? So it got launched in March, April of 2021, and that was the peak of the bull market. People in bull market usually do not have a sense of how to value things. In my opinion, the price movement is highly speculative, right? So if you're valuing a technology at you mentioned $700 price, right? I think that was around $90 billion valuation. Uh, a blockchain takes around like 5 to 6 years to reach that valuation. Even with Cardano, we saw 80 billion valuation in the bull market, right? And if you see, those valuations are pretty low as of today. So one, as a user, if you would want to invest in a blockchain, I would say look at the valuation of the project, and the valuation should be realistic. Market will not tell you the right valuation. To understand the right valuation, you'll have to know what that project is doing, who are the team members behind it, how committed they are, what research they have done, and how long they have been working on this product. I would say ICP, since people thought about ICP in 2016 or 17, it went into a research phase for 4 years, where private institutions like Polychain Capital, A16Z, they invested in the initial research of the ICP itself. And the tokenomics happened much later in the bull run of 2021. And even let's say if one would want to do a project either on ICP or Ethereum or Solana, anywhere, if you're coming up with your own tokenomics, I would recommend correlate your tokenomics to a traditional startup. A traditional startup would be valued at $13 million to $15 million in their seed round, and they'll be raising around like 1.5 to $2 million, right? And that's a realistic valuation you should be looking at. Doing your tokenomics around that will definitely give you an edge there in terms of maintaining legitimacy of your project. One thing you have to note here is you could only do tokenomics once, right? Once you have distributed the tokens, there is no way of raising more funds. So you would want to understand that your project essentially will act as a not-for-profit company in the future. True, you are a founder, you would want to make money developing this project and bringing it to life, right? So you'd have to value your project somewhere around where you know, like, hey, nothing could be done in 1.5 to $2 million, right? It's just a seed stage valuation. You think about a series A sort of valuation, think about 40 million, $50, and then design your tokenomics around it, that not all the tokens are vested upfront. They should have a vesting cycle. Community should have control over those vestings and what is happening. Seeing that valuation, then you get into a development of 4 years to 6 years of cycle, bringing your project to reality, and then ultimately transferring the control to a decentralized autonomous organization. And by that time, you should also think about how your project will make revenues. If a project will not make any revenues, your not-for-profit foundation or your DAO cannot exist in the future. These are the pointers I would guide to everyone, and think in a very, very practical terms.
That's a real good point, and thank you so much for sharing. So to follow up, what are some of those ways that ICP currently today makes revenue?
So ICP today makes revenue in the sense, the more the network protocol is being used, right? So there are certain social media applications. We have the decentralized version of TikTok. There are decentralized exchanges. All these projects are essentially using the compute and the storage on the ICP network, right? And to power this compute and storage, you need cycles, as I mentioned you before. And the way to get cycles is to basically burn ICP token. So that is the only way the price of the ICP token will go higher and higher, more the network is basically being used.
Thank you.
Really quick, Ritvick, building on that, when you say network utilization, because ICP is so different than some of like the others that are out there, where you can store data, you can make your DAOs on a canister, if I'm saying that right. How does ICP strategically think about what areas of specialization to have? Like, does people using it to store data have as much weight or value as people using it to, I don't know, do something else? Does that make sense?
So ICP wants what ICP wants is ICP want these traditional dApps who change their monetization and who are very capitalist in nature. The vision of ICP is basically to give access of a world computer to everyone. And in that case, you imagine all the apps we use as of today, the mailing apps, the accounting apps, the social networking apps, the gaming apps. Every app ICP would want to be hosted on the Internet Computer Protocol itself. So that way, you're not restricted to creating an app which can only do certain amount of compute. These are highly specialized servers, right? So AWS probably employs the same server as well, but then they have their own monopolistic costing over there. If you have to go and use their simple queuing service, you'll be paying for messages in and out. Imagine somebody could just build a queuing service on the Internet Computer Protocol itself. Then it's much cheaper for users to consume that basically. So the goal is basically for these DAOs to come together, build some reasonable projects which have real world applications. Most of it we can easily take from our Web2 world. And as innovation continues, more and more dApps will be built on this world computer, which is accessible in a fixed cost manner to everybody.
Understood. Makes sense. Thank you. Marlene, do you have a question as well?
Yes, I have a question. So you mentioned 6 years for the blockchain to basically, it almost sounded like a break-even expectation, but also with the recent rise of SPACs in a normal equity market, you also said like that the tokenization should be based on a realistic valuation. What is the basis of the valuation? Is it on a future expectation of network effect? So I use the SPAC example as an example where we've seen a lot of that valuation being used, you know, kind of on the future network effect. What would you say your valuation is, or what would be a reasonable valuation for something like this, given 6 years
Yeah,
of blockchain to kind of add value?
Yeah, I'll correct my statement. Yeah, so in 6 years, definitely a blockchain is adopted by the ecosystem, right? So when Ethereum came initially, people didn't realize what Ethereum was, and they were using Ethereum just as a money movement. And we sat through the whole bear market of 2018 to 21 till the point we saw legitimate apps like Uniswap and other DeFi related apps which were being built on the Ethereum protocol. And those dApps definitely got a higher valuation in the bull market. But that's how I think teams are strategically playing around as well. So think about in what currency you'll be raising the money in. If you are raising money, let's say in stable coins like USDT, USDC, you have to be very, very generous regarding your valuation. You cannot value your project just based on, let's say, a typical seed stage startup in the traditional company, right? Because they have the ability to raise more if they want to. So you have to think about it you need certain amount of funds in order to be working, keep developing. I would say at least for 4 to 6 years, because till then, if your DApp is too good, it will gain a lot of traction probably in a year or two. But if it is not, you need sufficient amount of money to convert that DApp into a self revenue generating model itself. If you don't achieve
Right.
that part, then your DApp will fail essentially.
Yeah, and that's why I'm bringing it up, because oftentimes there's private investment VC or whatever funds, and so some of that token valuation is based on their requirements, which are not really obvious. In the SPAC scenario, they use, for example, Monte Carlo simulations. So I'm just curious if there's some equivalent of projecting the network effect or projecting something for evaluation. I know it's an emerging space, but
Yeah, and even with any of the DAOs or any project, I would recommend seek for private investments initially. Let it be
yeah,
a private company in the traditional system till you develop a proof of concept, a minimal viable product at the point where you see traction coming in. And once that happens, then transition your private company into a DAO. Obviously, private company will reap some benefits as if the founding team reaps some benefits, initial investors will reap some benefits as well. But then you'll take those into the tokenomics of your token as well, and at that moment you might have a good idea how your DApp would be performing, since you already have MVP in the market and users are interacting with it.
thank you.
Any other questions, anyone?
Thank you, Ritvick. I was also going to add in addition to what to your question, Marlene, around modeling this. This is where, like, obviously historical data and being able to draw on large samples where you can, like in the case of Sabrina Howell, where they were looking at these 1,500 plus ICOs, and then they were doing some simple multivariate regressions. I think, like, looking at a community, looking at comparable communities, pooling those together, and then there's some methods in econometrics called like synthetic controls, where the idea is that there's not a perfect control group, but a permutation of different features of the different projects that are out there can be used to create what's called a synthetic control. So that's been used in, let's say, the United States, where you've got all the 52 states. And so there might be like one state that does a policy, and then you create a synthetic control based off of 15 other states or whatnot. So there's a lot of methods that are designed to sort of handle that, but it's very tricky because many times in this space, you just don't have that much data to go on. And what's good about ICP is that they're taking that kind of long run mentality around it, instead of just like saying everything, like the network has to grow by this much by like 2 years from now, otherwise we're going to call it quits. No, it's a longer run endeavor. And I think that perspective is helpful. So
And
thank you so
to
much.
add,
Yeah, please go ahead.
yeah, and to add there as well, the vision of ICP is very, very long term. So as I mentioned, you're right, in order to participate in the governance, you'll have to stake your tokens for 6 months, and you could stake your token from 6 months till 8 years. What that does is basically for 6 months, you'll probably not get any rewards for staking your tokens, but at 8 years, you get yield up to like 18% uh, for the amount you have staked. And the 6 months and 8 years is not something which you define initially, right? It is the fact that, let's say if I have staked my tokens for 8 years, if I go today and click unstake, it will take 8 years for those tokens to come back to me. And that's how the tokenomics is designed. And more than 25% of the tokens on ICB are staked for 8 years. So that shows the level of commitment from the initial investors, initial founders. They have a very, very long vision of, let's say, 10 to 15 years in terms of evolving this as a one world computer, I would say.
Yeah, this actually correlates nicely with our recommended reading on the paradox of genius, why long-term thinking wins. I was digging into that, and this is a nice example. Thank you.
You're welcome.
Wonderful. Well, thanks so much, Ritvick, for joining, for sharing, and educating me as well about how ICP works. And with that, I will stop the recording.